All right, so among the properties of log, let's look at the following property. So let me now bring up a few quick calculation examples here. So how about in base 2, we're looking at log base 2 of, and allow me to use red ink right here, of 1. And similarly, we can do log base 10, where I skip the base, of 1. And log base 0.75 of 1. And natural log, which is ln, where we write ln as log base e of 1. So we try a few different log in respect to different bases: log base 2, log base 10, log base 0.75, and log base e, or another way of saying this is the natural log. But these are all the logarithm operation that we take on the value 1. So log base 2 of 1, log base 10 of 1, log base 0.75 of 1, and log base e, or natural log, of 1. So you can see that my intention here is we want to evaluate different logarithms of 1. Okay. So on the calculator, I'm using the more advanced version of the TI calculator, but I will quickly swing over to the simpler version of the same calculator here, but with the simpler operating system. So now with this advanced TI-84 plus CE calculator, let's look at log base 2. So notice that this calculator does not offer log base 2 or any base other than base 10 and base e. So we can do the following. We want to go log base 2 of 1, meaning we have to do the following trick. We can make a choice between log base e and log base 10. So I'll go with log base e. It's just simply something that I'm more comfortable with. You can also choose a log base 10 here. But I'll go log base e, or natural log, of 1, and divide that by same log, natural log of 2. Okay, this is to evaluate log base 2 of 1. But this is the trick to get the logarithm calculated for any base other than base e and base 10 right here. So natural log as a choice, natural log of 1 divided by natural log of 2. The answer is 0. So now that answer here equals 0. Let's now try log base 10 of 1. Now for log base 10, the key is ready right here for us. So log log base 10 of 1. So we put 1, we close the parentheses. This is our answer. So now once again back on the writing board of mine, log base 10 of 1 equals 0. So notice the repeat in our answer that we've had right there. Log base 2 of 1 we have found previously equals 0. And now log base 10 of 1, it's a different calculation, but look at how the answer is repeated. And now let's advance to log base 0.75 of 1. So now back on the calculator, again, 0.75 is a base other than base 10 and base e, so I'm going to make a choice. We can go with log base 10 or log base e right here. These are the only two choices available with this calculator I'm using. So I'll go natural log of 1, because really the problem is log base 0.75 of 1. So I'll make my choice. I made my choice natural log of 1 divided by natural log of 0.75. So this value comes out from the base of the original log problem right here. Let's now hit enter to obtain our final answer. All right, so now this is the answer for log base 0.75 of 1. So I have the answer here equals 0. And let's now look at log base e, or natural log of 1. Now back on the calculator. This is simply just pressing that button right here, which is already available with the calculator. Natural log of 1. And this gives me, after I hit enter, 0 again. So on the board, natural log of 1 equals 0. And so at this point, there's no reason to try out with any other log, try out a logarithm of another base. We have tried a log base e, a log base 0.75, a log base 10, a log base 2, some general bases, and then this is common logarithm, and this is a natural logarithm. The point of this property I'm about to show now is that when we have the logarithm of whatever base, but of 1, logarithm log base 2, log base 10, log base 0.75, log base e, on any logarithm of 1 will turn out equal 0. So we formulate the following property to remember, and it should be simple enough to remember this. So log base a generally of 1 equals 0. And this is a property that I don't think anyone needs to remember this, because as you will keep seeing that through your evaluation problem, then it will stay in your memory. Now, aside from using the calculator to demonstrate, to prove this logarithm right here, we can also think about, if we now pick a base a right here, log base a of 1. Now I'm trying to give an alternative explanation for the general case instead of focusing on base 0.75 or base 2 or base e or base 10 like we have done throughout the tryouts earlier. So generally now when we're looking at log base a of 1, where a can be any base, whichever answer this will turn out, recall from the definition of logarithm that log base a of 1, if it equals x, it means, so this double head arrow here means, verbally it says means. So this statement here, the answer to log base a of 1 equals in value x, means a to the x equals 1. And assuming that we are well aware that the base for any logarithm is positive base and other than 1, then the only way for a to the x equals 1 x must, as a must right here, x must be equal, because that's the only way. Or as another way of explaining this, for any base positive and other than 1. Now if we raise that base to a power 0, algebraically it will equal 1. And so now this statement in exponential form can be re-expressed, or this statement means the same way as saying log base a of 1 equals 0. That's another way of saying it. Most ultimately, according to the way how I started out introducing about logarithm, then when we're looking for the answer to log base a of 1, recall that we brought up the following question: what power of base a equals 1? Okay, And so we brought up the following concern here. What power of base A? So I used, when I introduced about logarithm, I used this picture over here, an empty square over here, that we could think about a power, what power of base A, that it can equal 1. And so apparently that power must be 0. And so those are a few different ways of explaining why log base A of 1 for any base right here must equal 0. So from now on, as a quick example, anytime we're asked to evaluate log base A of 1, needless to use a calculator, the answer will come out as quickly as 0, because we are utilizing this property of logarithm.